Hello, and welcome to this video on electromagnetism, where we're going to be discussing solenoids. This is for GCSE physics. In this video, we're going to be talking about electromagnetism, what a solenoid is, how to make one, what affects the strength of a solenoid, the field lines around a solenoid, how to make an electromagnet, and several uses of electromagnets. A current-carrying wire, a wire with a current passing through it, has a magnetic field around it. This field is in the shape of concentric circles, and the field stops when the current is turned off. This field can be made stronger by increasing the current through the wire. Another way to make the magnetic field stronger is to coil the wire up into a shape called a solenoid. A solenoid is a wire that is being coiled up. If that wire is part of a circuit and has a current flowing through it, the solenoid will have a magnetic field around it. The magnetic field is similar to the field around a bar magnet, except that the field lines go through the middle of the solenoid. These field lines are parallel to one another. Where the lines are parallel, the field is strong and uniform. So far in this video, you have learnt that a current-carrying wire has a magnetic field around it. You have learnt that the field can be switched on and off, and that the field looks similar to a bar magnet. This knowledge can be used to build and test electromagnets. To build an electromagnet, you will need an insulated wire, a battery, and an iron core. Wind the insulated wire around the iron nail, which acts as the iron core. Connect the ends of the insulated wire to the battery. You've now made yourself an electromagnet. You can test the strength of the electromagnet by placing it near paper clips and seeing how many it picks up. Your independent variables could be either the number of turns, the amount of current, or the material of the core if you want to make this into an investigation. Here we have an investigation into changing the number of turns on an electromagnet and seeing how many paper clips have been lifted. So the number of turns have changed from 40 to 60 to 80, and we have the number of paper clips there, and the mean number of paper clips are 15, 21 and 26. As you can see, the conclusion for this is as the number of turns increases, there's a greater number of paper clips picked up. And you must say number of turns. In an exam, you've got to say you're changing the number of turns, not the number of coils. The strength of a solenoid can be increased in three ways. We can increase the number of turns, not coils, increase the current, or we can add an iron core. For your GCSE, you need to be able to interpret diagrams that involve electromagnets in order to explain how they work. Here are a few that might come up. This is the electric bell. The first stage in the electric bell is to close the switch. This turns on the electromagnet. The electromagnet then attracts the iron armature, and the hammer hits the bell. This breaks the circuit. The electromagnet then turns off. The iron armature springs back, which remakes the circuit and turns on the electromagnet. And this repeats the process all over again. The electromagnet is turned on. This attracts the iron armature, which then makes the hammer hit the bell. The circuit is broken. The electromagnet turns off, and the iron armature then springs back. This process repeats, and you have a ringing bell. Relays can be used to switch on a second, higher voltage circuit. You switch on a low voltage circuit, and this is used to turn on a second, higher voltage circuit. This is much safer for you. First of all, close the switch. This turns on the electromagnet. And this electromagnet then attracts the iron armature. As the iron armature pivots around, it pushes on the contact. The contacts touch, and this completes the second circuit, and that starts, in this case, the motor. Trip switches are designed to break an electrical circuit if there is a surge in the current due to a fault. This protects the appliance from further damage. Trip switches are also easy to reset. They work in this way. The electromagnet is always on, but the current is low, which means the strength of the electromagnet is also low. If there is a surge in the current, the electromagnet becomes stronger, and it's now strong enough to attract the iron bolt. The iron bolt moves to the left, and this releases the plunger, which breaks the circuit. The circuit can easily be reset by pressing the reset button. And that's the end of this video. Thank you so much for listening.